When you look at that picture, what's one piece of the picture that you see? What's one concrete thing you see? You see a right angle. That's really important. You see a right angle. What else do you see? That blue thing. What's that blue thing at the bottom?
Plane.
It's a plane. Okay, so it's a plane. There's a right angle. That segment from x naught, y naught, z naught to x, y, z, where does that segment live? That's really important. Where does that live? On the plane. That segment is on the plane. It's in the plane, or however you want to say it. On the plane is totally fine and sounds a lot better. N is any vector that is what in relation to that segment? Perpendicular to that segment. That segment, where could that segment go on the plane? Like, where could x, y, z be? Anywhere on the plane. So this is really, really important to understand the setup here. This represents any point on the plane. And what does this represent? Anybody know why it's called the n vector? We're going to use n a lot. Like U stands for unit vector. What's n going to be? Does anybody know what n is called?
Is it?
Yeah. Tie goes to the... Ready, 1, 2, 3.
Normal.
There we... Oh, look at that sharing.
That wasn't normal at all.
Normal. Yeah, perpendicular. So that represents any vector that is perpendicular to the plane. And x, y, z represents any point on the plane. And x naught, y naught, z naught is some fixed point on the plane. You with me so far? What do you know if I tell you, let's say n is just equal to this vector, a, b, c. If two vectors, and we'll call one of them n, and we'll call the next one starting at p naught going to p. If two vectors are perpendicular, what do you know? What's one relationship between them that you absolutely know? You learned it yesterday, and you were working with it a little bit. The dot product is 0. This is super important. If two vectors are perpendicular, the dot product is what? 0. Remember, we got that because we had this statement. We had what? v1, w1 plus v2, w2 plus v3, w3. Those are the components of the three vectors equal the magnitude of v times the magnitude of w cosine theta. What's the only way for the right-hand side to be 0? When theta is pi over 2 plus pi n, or 90 degrees or 270, which would be perpendicular. So that means the only way for this to be perpendicular is for the dot product to be what? 0. So we go back over here and we have a dot product of 0. But what are the components of A? A, B, C. And what's P? You're going from this point here to this point here. Can someone tell me what the change in x is? Yeah?
X minus x sub 0.
X minus what?
X sub 0.
Yeah, Sub-Zero is kind of cool to say, mainly because it's a Mortal Kombat character. But the way it's Sub-Zero is fine. X naught, Y naught, Z naught. And how do you spell naught? N-A-U-G-H-T. All for naught, all for nothing. X naught, Y minus what? Y naught and Z minus Z naught. And we know that that has to equal 0. Do we know how to actually compute algebraically the dot product at this point? Yeah, it's going to be A times what? X naught plus B times what? Y minus Y naught plus C times Z minus Z naught. What did X naught, Y naught, Z naught represent in our original picture? Any point on the plane. And what does ABC represent? The components of the what vector? It's actually not super specific of me, it's not accurate of me, it's any normal vector. So ABC, the components of any normal vector, x naught, y naught, z naught, any point on the plane. Can anybody tell me what we now have right here? Anybody know what this is? Does that kind of look vaguely familiar? It looks like equation, some sort of an equation. That is the equation for a plane. That is the equation for the plane that passes through the point x naught, y naught, z naught that is perpendicular to the vector ABC. This is the equivalent of point slope form for planes. This is the equivalent of point slope form for planes. Why is this super useful? It is super useful because we can do things like this. Emily, give me any three smaller numbers that you want. Any three. 4, 7, 9. Cade, give me any three numbers.
1, 2,
4. I could ask you, what's the equation of the plane that passes through the point 1, 2, 4 that is perpendicular to 4, 7, 9? Meaning you're looking for a plane that passes through this point right there that is perpendicular to this vector right there. Can anybody tell me what the equation is? It's right there. Use the equation that's right in front of you. What's the a value? 4. So it's going to be 4 times plus plus z minus equals. That is the equation of the plane that passes through the point 1, 2, 4 that is perpendicular to 4, 7, 9. How many pieces of information did you need to write the equation of a line in two dimensions? You need a point and a slope, right? Or 2 points, but 2 points give you the slope, so you just need point and slope. Here, for a plane, you have a very, very similar situation, but you don't need the slope of the plane, because how many different slopes are there on a plane? Well, there's lots, depending on what direction you're going in, right? Instead, you need any vector that is perpendicular and any point on the plane. You might think that's super general. Couldn't you pick a different perpendicular vector? Well, sure. Let's say, what's another vector? Let's call this one n1. What's another vector that's parallel to this one? Can someone give me another vector that's parallel to this one?
would like 8, 14, 18.
Exactly, 8, 14, 18. Now, if I use that vector, if I use that normal vector instead, Nate, where would the 8, 14, and 18 go?
Just in place of
But then what could you divide this whole thing by? 2. And where are you? Back to where you started. If it's a linear combination, you can always divide out the scalar multiple, because what's over here? 0. 0 divided by anything is going to stay 0. So it can be any perpendicular vector. So if you're looking for the equation of a plane, you are effectively done when you have any point in the plane and what? Any normal vector. Any normal vector. You're going to practice some of these. I'm going to give. What was that statement for dot product? What was that equality? It's okay. There's an algebraic side to it, and I need to unfreeze this so you can see it. There's an algebraic side, which is the left, and the geometric side. It was. Do you remember what it was? V1.
V1 times
V1 W.
V1 plus V2 W2 V3 W3 equals the magnitude of V times W plus cosine.
Cosine theta. What does that mean? It means that theta is equal to cosine inverse of what? V1 W1 plus V2 W2 plus V3 W3 divided by magnitude V, magnitude W. So if you have the components of two vectors, what do? You do the dot product divided by the magnitude of the two vectors and do the cosine inverse of that. Does that make sense?
Do you do it in degrees?
Good question. At this point, since it doesn't specify, you could keep it in degrees because it's really these are not nice ones, I don't think. I think these are all kind of nasty ones. In general, though, on the AP test, you keep things in radians unless they otherwise specify. If you do go to degrees, you have to go to 3 decimal places or it's not going to be correct. Does that make sense? So we'll start with this. The magnitude of V parallel. What's the magnitude of that going to be? Oh, come on. You can do it. Yes. V, be careful, not V. That's a V. These are V's. V and V. V. These are all V's. Okay, sorry, I understand. So the magnitude of V parallel is going to be equal to the magnitude of V times what? Cosine of theta. What's the magnitude, and we haven't talked about it yet, but what's the magnitude of V perp going to be equal to? The magnitude of V times what? Sine of theta. Are you with me so far? This is just trig in a right triangle. This is a right angle. I'm not trying to make it impossible by creating some sort of weird relationship. Are you with me so far? Okay, so this represents, right here, everybody with me? This is important. This represents the magnitude, so the length of this vector, right? What direction do we want it to go in? u. We want it to go in the u direction. So if we wanted to find the vector representation of this v parallel, basically not the magnitude, if we wanted to find v parallel, we would need a direction and a magnitude. Do we have the magnitude? Yes, the magnitude is right here. What's the direction it needs to go in? U. What's the magnitude of u right now? 1. So what's the magnitude of 7u? 7. What's the magnitude of 8u? Is it always the case that the magnitude of a vector is equal to the coefficient of the vector? No, because the vector itself could have a magnitude of something other than 1, right? But in this case, what's the magnitude of u? It is what the magnitude of u is the coefficient, but the magnitude of u is 1. So if we want to go in this direction with this magnitude, this direction with this magnitude, we can pretty nicely find out what is v parallel. Not the magnitude. What's the magnitude of it needs to be this, right? But what that's a scalar, right? What direction do we need to go in? There it is. What's the magnitude of this vector right here? It's that, right? Because what is the magnitude of u? 1, so it's just the coefficient. So what do we now have? We have this vector, which is the magnitude of v cosine theta u. Now this is where we have to pull something out of thin air, kind of. You're going to see this in your math career several times in your life, many times, and it's kind of frustrating, but here's the thing. U is what kind of vector? Unit vector. I was trying to hammer that because we now get to do something that seems super arbitrary. We get to do something that seems super arbitrary. Do I change anything if I do this? Tell me if anything changes. Ready? I'm just going to do this. Do 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 do. Tell me if anything changed. Did anything change between line 2 and line 3? What's the only thing that changed between line 2 and line 3? What did I add in? No, the direction is here. That's the same. This is the same. This is the same. What's the only thing I added in? The magnitude of u. But what is u? What's the magnitude of u? 1. So has anything changed from here to here? Can anybody tell me why I added that in?
Because you can use that formula.
Exactly, Nate. What is this? What is this?
That's the geometric definition of the dot product.
Exactly. So guess what we can now write? V parallel is equal to u dot v times what vector? U. The underlined green, they are the same thing, right? We just went from the geometric to the general statement here. We can find it any way we want. But the point is, if you want to know the force of the component of force in the direction you want to go in, what do you just need to know? You need to know the force vector, and you need to know the unit vector for the direction you want to go in. You take the two, you dot them together, and you go in that direction. This allows us to find v parallel, which is super helpful because it's the component of force in the direction that we want to go in. So if we do all this stuff to find v parallel, what do you think the easiest way is to actually find v perp? Not the magnitude of v perp, but v perp. What do you think the easiest way to go about finding it is? I'll give you a hint. You don't need to do any of this algebra. Can someone tell me the relationship between v perp, and v parallel based on the picture right there? Plus 90 degrees? What'd you say? See how books explain things? The whole key to all of this is this. I remember looking at this for the first time years ago and being like, I don't get it. Where are they getting the dot product from? It all comes down to this. Adding in the magnitude of u to turn it into the dot product. It makes it easier to write. Okay, so here are all the relationships that we just talked about. V equals that addition right there. V perp is that. This has to be true, and this is this is really big. Do you see that word projection? Do you see that word projection? V parallel is the projection of V onto U. Do you see that? Like if you had a light shining down, it's this projection. Sometimes you will look, if you look at other calc textbooks, they don't call it V perp and V parallel. They use projection and I forget the other word, but I'm trying to forget it so I don't confuse myself. Okay? it kind of is annoying that they're... To translate this question, we are given this vector right here. Here's F, here's the force. Which vector are we trying to find? That vector right there. We're trying to find that vector right there. So we know that the magnitude of F parallel, do you remember what the magnitude of F parallel is going to be? That's the projection. Do you remember what that's going to be? It's going to be the magnitude of F times what? Times cosine of theta. Are you with me so far? Let's pause for a second. You get the dot product times the direction you want to go in. Exactly. Okay. Last. That is the dot product of what? F and D. So this is really, 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 really helpful. So if we start off with work is the force in the direction we want times the magnitude of the distance, we do one step. Oh, we know that F parallel is the magnitude of F cosine theta. Well, this carries down right here. But what is this? Oh, we rearrange it. Oh, look what we get. Dot product is the kind of thing I think that came up so many different places that they gave it a special name, and no, I don't have a good reason for why it's called dot. Okay, 1:30, get out of here. See you, kids.